Hi scholars, today we are going to continue on our exploration on circuits. So yes, today and tomorrow we are going to be doing a two-part lesson on series and parallel circuits. Today we are going to explore what happens when you have multiple light bulbs connected to a circuit and what happens when they're connected in different ways. Today we'll mainly be doing a FET simulation activity that's going to help us to answer the question, does the way that the light bulbs are connected in a circuit affect the brightness of the light bulbs? Right? So like I mentioned, today is going to be predominantly a FET simulation, and then we're going to do a check for understanding. We'll go over some key points, and then we'll do a quick exit ticket. For today, you'll need your notebook to write down key points and just your classwork document. Great, so like I mentioned, we are going to go through a FET simulation. So that is linked in your classwork document. In a minute, I'm going to give you some time to go ahead and open that up. But first, you are going to, so just keep in mind that as we're completing the FET simulation, you are going to keep these following guiding questions in mind while you're doing the activity. Right? These are also in your classwork document, and you can take a few minutes on your own to read this afterwards. Just wanted to name it so that as you are going through exploration, you can keep these questions in the forefront of your mind in order to more effectively answer them afterwards. Right, so now let's go to your classwork document and see exactly what you need to do today. Okay, so here is our classwork document. You are going to click onto this link, and it will bring you to this simulation. I'm going to clear this. So this is familiar for you already. We've already used this a few times, this unit. And so here my instructions tell you that you are going to predict the brightness of the light bulbs. And then you're going to build the 5 circuits that are shown below. You're going to do it one at a time. And then you're going to fill out the results column with your observations, and then add an explanation based on your observations. So these are the 5 circuits that you're going to draw. And before you draw them out, write a prediction here about how the brightness of the light bulbs are going to be affected. And then here you're going to write your results. And then here you'll add an explanation based on your prediction and your results. Okay? And then again, as I mentioned before, keep these 4 questions in mind while you're exploring the simulation, because after we're done, you are actually going to have to answer those questions. Okay? Before you move on to start your work, I just want to remind you how this simulation works. You're going to click the component that you need, and then you drag it onto this work surface. So if I'm drawing this circuit here, A, I need my my battery, then I need a wire. There's 2 light bulbs there, so I need 2 light bulbs. Connect that there. Need another light bulb, another wire. And then I need, and lastly, need another wire here to connect these 2. I'm not going to connect it. I want you guys to first predict what you think is going to happen and add it into the table. All right, you're going to take the next 15 minutes to complete drawing all of these circuits and add in your predictions or results. You can press play on the video when you're ready to come back and go over the check for understandings. Okay, press pause now. Okay, so now you're the check for understanding is to answer the questions that are below based on your observations. Take the next 5 to 8 minutes to answer these questions on your own. Once you're done, you can press play to come back to the video. Press pause now. All right, so let's take a look at your responses. So did the arrangement of the light bulbs affect the brightness of each bulb in a circuit? So you could have said either yes and no. Actually, it depends. We saw that yes, when the number of branches and the number of branches and light bulbs did have an effect on the brightness. And then also we saw that the order of the two light bulbs in the same branch didn't affect our circuit. All right, let's look at the second question. So did the order of the light bulbs affect the brightness of each bulb in a circuit? What did you say? Right, so no, when we tested circuit A and B, we saw that the light bulbs had the same brightness regardless of how they were ordered. Okay, good. So third question, did the number of branches affect the brightness of each bulb in the circuit? And by branches, it means like how many times did it break off from the original wire in the circuit? And we saw that, yeah, when there were two light bulbs over two branches or paths, the light bulbs were brighter than when there were two light bulbs in the same branch or path. All right, so when two light bulbs were connected together, they were dimmer than when two light bulbs were connected in different paths. Interesting. And then the last question is, did the number of light bulbs affect the brightness of the circuit? So you should have said yes. The light bulb in circuit C, when there was only one light, was much brighter than the two light bulbs in circuits A and B. And so when there was two light bulbs together, connected next to each other, they were dimmer when there was only one light bulb. And how did that compare to the brightness of the bulbs when they were in two different branches? We're actually going to explore that a little bit more tomorrow. All right, moving along. So you can take out your notebooks now and write this into your notes. These are important key points that you need to know. And we're giving some names and definitions to the circuits that we saw. So the first key point is that a series circuit is a closed circuit in which the current only has one path to take. So here we have the battery, and then there's one wire coming out of the battery, so the current flows through this one wire. And this current goes through this one light bulb, it continues on, and goes through the other light bulb, continues on, and then back to the battery. Right, so this is a series circuit. Draw this into your notes, and make sure you label this correctly. If you need to, press pause now to make sure you have this down. Okay, next key point. A parallel circuit is a closed circuit in which the current divides into two or more paths or branches before recombining to complete the circuit. Right, so here we have a little bit of a different situation. The current comes out of the battery, right, so it comes out, follows this one wire, and then over here reaches this point or reaches a junction. So here the current has to decide what it wants to do. So it's actually going to split. Some of the current is going to go through this one light bulb, and it will continue on. And some of this other current is going to continue on from this path, and it'll go through the light bulb, and it will continue. And then when the current reaches this other point here, this other junction, then it's going to add up back together, continue on its path, and then back to the battery again. So this here is a parallel circuit. Again, if you need more time to write this into your notes, press pause now in order to do that. All right, moving along. This is just another diagram to help us visualize what's going on. So a series circuit has the battery and several light bulbs that are all connected together. They're connected in series. That's why that's called that way, where they all follow one another. Current goes through, and then it comes back to the battery. And then these are called parallel circuits because the light bulbs are connected and parallel to each other. Okay. So now go back to the table, and then the exploration section, the last column of your of the table, add to each circuit if it's a series or if it's a parallel circuit. Okay. Take the next minute or two to do that. Okay. You should have noticed for yourself that this first circuit, that A and B, are both series circuits. And then D and E are parallel circuits. Right? C is neither because it just has one light bulb. E is interesting because it has light bulb 1 is in parallel with light bulbs 2 and 3, right? So they're parallel to each other. But then if you look within the circuit, actually bulbs 2 and 3 are in series with each other, right? So you can have a circuit that has a combination of both setups within one circuit. All right, cool. Last key point for today. So in a series circuit, as you have observed, the number of light bulbs affects the overall brightness of each light bulb. As the number of light bulbs in a circuit increases, the brightness will decrease. And we see that here. I took a screenshot of our simulation. We see that if with only one light bulb, the brightness is represented by the length here of my light rays. Right? So one bulb is really bright, 2 bulbs is a little dimmer, and then when I have 3, it's a little dimmer, and then so on and so forth. Okay, so take the next few seconds to write this down into your notes as well. Okay, so our exit ticket for today is: how can the arrangement of the light bulbs in a circuit affect their brightness? All right, so in your own words, you're consolidating everything that we just discussed. And for tomorrow, we are going to be diving a lot deeper into what parallel circuits are. So for today, we're just wrapping up kind of the last key point was about series, but we didn't talk about how the brightness is affected in a parallel. Okay, that's it for today. So make sure that you wrap up all your classwork and that you submit it to Google Classroom. And that's all. I hope you have a wonderful day and take care.